yeah, like what Sam was saying about coming to, getting your start at these. When I moved to Boulder, 2006, I started coming to this meetup, and yeah, I got, met a lot of interesting people and learned a lot from it, so it's great. Haven't presented in one in probably 10 or 11 years, so, and but I've had a hectic couple of weeks, so I just finished my slides last night, so this isn't as polished as I'd like it to be. But anyway, I've been doing Rails for, since 2011, so 2004, 2005. That's kind of all I've been doing. Like I do a little front end and kind of DevOps, but yeah, mostly focused on Rails. You can find me at GitHub/Paul, and I'm on Twitter. And I'm the lead architect at TextUs. Been there for about 2.5 years now with JF, and we just hired Brooke a couple weeks ago. Yeah!
Congrats, guys.
Rib house.
Okay, rib house.
What is the roadhouse?
Rib house.
So I'm going to talk about dry transaction, which is, so since the beginning of Rails, there's always been this tension of like, where do you put your business logic? In the early days, Rails 1, 2, 3, like it was always, you just put it in your models because that's where all your code lived. And but if you had some action that involved multiple models, like you put some of the code in one, some of the code in the other, and a controller would just kind of try to juggle between them. And then if you needed to reuse it, then like you used just a helper. Like you just never broke out of the MVC patterns that Rails gave you. And that approach was probably called, you've heard it called fat models, and turns out it was a maintenance burden because changing one part of a model might break some other model completely unrelated, just totally unexpected. And if you put it in controllers, like it's really hard to test those because a helper method, like there's all this setup you need, and it's hard to set that up and then just test that one thing in isolation. And so then, quite a while, 10 years ago, some Rubyists started exploring code patterns found in other languages. Like these 2 books were very inspiring, Design Patterns and Patterns of Enterprise Application Architecture. The designs in this book were mostly tailored for C++ and Java, and so a lot of them are just completely unnecessary in a really flexible language like Ruby, but there are a handful that work extremely well, and you've probably used some of them or used a gem that implements some of them. So you break it out from the model into all these different kinds of objects that are categorized as service objects. And a lot of them, like again, because Ruby is so flexible, you can implement some of these in less than 100 lines of code, but a lot of them are fairly trivial. So like, there's gems that do decorators and view models and presenters, and then form objects kind of wrap everything you need to know about a form. And a command is an object that usually just responds to call and does one thing and does a series of steps in a very procedural way, and then when it's done, it's done. And so the dry transaction is like the command pattern on steroids. So yeah, the command pattern is, you can recognize it usually as an object that defines a call method, and that's usually it. Sometimes it's common to see a command object that has a couple public methods that are named just as verbs, like do something or authenticate user, or the command object itself is named as a verb like authenticate. And so here's a command object, and there's no gem involved here, but it starts out, I named the class as a verb, authenticate user, and it initializes with some config and some dependency injection, which that's another talk. And then there's a single method call, which takes some input and does some things and returns some output. And this code is okay. It's certainly better than having it all in the controller. It's still not great. It's procedural, and it follows a fairly linear set of steps. But because some of these things can go wrong, it kind of has to jump around. So like something that could go wrong is like if there's no token or the token is invalid or expired. The JWT gem we're using here raises an exception when that happens. So we need to rescue it. And that happens down here. And then we return nil. And then, but the token could be valid or it could be missing some data. So we're back up here now and we return nil again. We need to have that sub key or we can't continue. So we have to bail out early. Again, the user could be missing or not found. So we have to have, an else clause to decide what to do. And then also on top of that, like all three of these errors, could be, they need to be handled differently. Like you want to tell the user, with different HTTP status codes maybe that like, this one needs to redirect and this one needs to return a 401 and this one's an okay, keep going, we have a user. And so we could do that with like multiple return types, raising different exceptions within this class that something else would have to rescue. But that just means we'd need more conditionals and more, the code flow would get broken up and moved all over the place. And so that's a good step. It's better than having it in the controller, and it'll get you pretty far if you're very careful about keeping the size of those objects small and breaking them up so you can compose them. But then you want to compose it so one command can call another, and then that one calls another, and then maybe that one decides like I need that one or I need that one. And then this starts to cascade in a way that can get really difficult to trace through all your command objects, like which one is doing what. And if one of those ones in the middle fails, how do you, outside, how do you know which one failed? How do you decide all that? What's responsible for detecting an error and letting something else know? And so dry transaction helps with that. And dry transaction is one of a suite of gems by a team that goes by dry-RB. And these gems are all just like, some of them are really low level and some of them kind of build on that and some build on that. And so like these are all really fascinating gems. They're a really big departure from the Rails code that you might be used to. And there's a lot of just interesting ideas, and just reading through the source code of some of these will probably make your Ruby code better. There's a lot of really advanced Ruby tricks you can learn from reading through it. It's much more like the original spirit of Ruby before Rails kind of segmented off, like here's how you do web applications. But Ruby is like this big language that does a lot of other stuff besides just Rails. And none of these have anything to do with Rails at all. They don't care. Some of them like include a rail tie so they can be used in Rails pretty seamlessly, but for the most part, they're all just standalone. And dry-RB is also, you've heard of the Ruby object mapper. So it's kind of a lot of overlap in the teams, and ROM uses a lot of the dry gems under the covers. And then another one is Hanami, which is kind of an alternative framework for Rails that like learns a lot of the lessons that we've learned in Rails over the last 10 years. And so it's Rails, but with cleaner code and sounder engineering principles. But it builds upon ROM and includes a lot of the dry-RB gems and has a lot of interesting ideas on its own. Even if you don't end up using Hanami, it's worth reading through their guides and seeing how they do things and how you can use that in Rails. So dry transaction is one of the higher level of the dry-RB gems, and it's a business transaction DSL. It provides a simple way to define a complex business transaction that includes processing over many steps and by many different objects. It makes error handling a primary concern by capturing and returning errors from any step in the transaction. And so this is just from their website. It kind of talks about how the high-level concepts.
Is it okay to ask questions or should I skip to the end? Okay, that was not my question. It says a business transaction doesn't have any state. That means that all the state is passed in. It doesn't retain any state. Is that correct? Because obviously you need some kind of state to do something. Okay.
You can, I'll get into this, but you can initialize it with some config that usually doesn't change over the course of the runtime, and then call it a whole lot with
passing up
different parameters.
Gotcha.
varies based on the parameters, but the config always stays the same. So you might pass in, credentials.
Sure.
And, you always use those credentials when you're talking to a third-party API, but you might be making different API calls inside that depending on the input.
Great, thank you.
All right, so we had that authenticate user command objects, and let's break it apart into a dry transaction. So I'll go into more detail on what all of these things, but it's follows the same kind of pattern. We have an initialize function that takes a config and some dependency injections, and one of the dry RB gems is dry container, which is a really powerful dependency injection library, and dry transaction just handles it out of the box. Maybe we'll get into that depending on how much time we have at the end, but that's kind of what those double splats are doing at the end of the initialize. It's passing it into the container so it can set up with some more things. And so the next we have a series of steps. You specify using a DSL that lets you customize how each step is run and how the output of that step is handled. So each step definition takes a symbol as an argument, which maps to a method that you define later in the transaction. And they can take some optional options. And then the steps run in the order that you define them here, one after the other. And the return value of one step is passed into the input of the next step, the arguments coming into the next one. And so, and then if one particular step fails, the transaction stops running the steps and bails out early with a failure saying hey, here's the step I failed on. And so you can, it's really easy to, so this verify JWT token, here we're saying, catch those exceptions. And so what this step is doing without you having to rescue or do anything, if this method returns any of those exceptions, this whole step returns a failure and it stops processing and it doesn't go any further without us having to rescue or doing ifs or return early or anything. And it's really easy for the caller of this transaction to examine what it got back from the call and know exactly what step failed and how to handle it. So let's dig into what a step is. So, here's a much simpler one than authenticate. So when writing a transaction, you'll use what are called step adapters. The authenticate, we had a bunch of different steps. But all of these are just wrappers around a basic step, which a step has to follow some very specific rules. The main one is that every step must return a literal result object, which can be a success or a failure. So, the success or the failure here. And dry transaction provides a few helpers to create the result objects, those success and failure methods with the capital letters. They're a little odd, but they take advantage of Ruby in that a method can have any name. Any UTF string for the name. So Japanese characters, emoji, even white space are legal method names, but don't do that. So in this case, the method starts with a capital letter, which makes it stand out and look like a constructor function in other languages.
I was gonna just add to that, Paul. The one thing I like about that too is in Ruby, if you've seen the casting done, when you do array casting or hash casting, integer string casting, where you do string capital and pass in a string, right, and you cast it, you're casting it to a string. So in this case, another way to think of that is kind of like being able to cast to a monad, right? You got your sorry, Paul, I'm jumping ahead a little bit.
He's excited.
But this is kind of neat to think of that, right? You have a success object or you have a failure, but you can kind of think of it as casting if you're familiar with the normal casting native to Ruby. So, sorry.
So what we're doing is we're declaring a step here called do a thing, and then we implement the step do a thing, which takes some arguments, and then we're checking something about the arguments, and if it's not right, we return a failure. Otherwise, do some work. So here we're string bashing and returning success with the value of the string that we're done with. So if that step returns the failure, this transaction stops. It's done. And the second step never runs. But if the first step returns a success, then it passes the value of this success in as the argument into the second step, and we can do some more work. And because of that, we know for a fact that value can't be nil or can't be something we didn't expect because of the work we did in the first step. And so you can see, like, if we call this transaction with a foo, we get a failure from this failure that says, oh, that was a foo, I can't do it. But if we call it with a bar, then this runs, returns the success that says, here's the results of all my work. So to understand what's going on here, though, we need to dig into what success and failure are. They're a result, like a literal result object, which is, it's an idea borrowed from type language. I think it originated in Haskell, but lots of other functional languages like Elm and Rust use this concept. It's called a monad.
I want to slow you down.
So monads are monoid, a category of endofunctions. Clearly. Which is, I don't know what that means.
Okay.
A monad it can be a fairly abstract concept in some of the other languages like Haskell and Rust. But for our purposes, it's really easy. It's just a simple wrapper around a value that can be multiple distinct things, but you can't access those things without going through the wrapper. And all of the possible types of the wrapper implement the same set of functions. So you can just call through, like, no matter what you have here, whether it's success or failure, you can call the exact same methods on it. You just can't get straight to the value. And so the simplest monad is probably, it's called a maybe, or in Rust they call it an option. And all it does is wrap something that could have also been nil. And so this is, you've probably come across this, where you're running some code and without even knowing it, it's totally possible that it could return nil. Like, this could happen anywhere and you don't know, you just have a nil all of a sudden. And so you get a 500 error in your Rails application, like, hey, undefined method, whatever on nil. And that's because you didn't know that this had an opportunity to be nil. And this could have, something could have called this, it'll pass all the way through a bunch of objects and it gets all the way to you. And it tells you, hey, there was an error in your ERB template on nil. That's not helpful. Where did that come from? Who was responsible for generating that nil? And you have to go through this laborious debug process to figure out where that nil came from. And so what the maybe monad does is, so maybe is a wrapper that can contain only two possible values. So this is the terminology that Elm uses. So there's a maybe can be just, which wraps a value, or it can be nothing, where there's no value. And in Elm, you can, the maybe has two possibilities, nothing and just a value. The just is a container that holds the value, and nothing replaces the missing value. So in Elm, this is useful because we can declare a function that can, the argument is maybe, and it will, when you have a result, you call this function on your maybe, and the function's like, okay, yeah, that's fine. And that result can be a just or it can be a nothing. But the Elm compiler will detect if you've correctly handled both cases of the maybe. So so here we're saying case maybe of nothing, do that. And if it's just X, do that with X.
So you're saying if I omitted lines 4 and 5, the compiler would say, hey, dude, handle your code. Sorry. I was not planted. That question was not planted.
The Elm compiler knows from the type, maybe is nothing or just a value, and it can refuse to compile. It's like, hey, you didn't handle the nothing there. Like, what happens if this thing gets passed in nothing? I would have to crash. So you need to handle that nothing, or I'm not going to compile. So in Ruby, we don't really have the help of a compiler to detect these problems.
We don't need it.
Yeah.
Sorry, guys.
Use the baby monad to get a better error. So in Ruby, there's a dry-monads library that implements these exact concepts. So, we require dry-monads and we extend using this weird syntax that the dry RB gems really like, which is really interesting to dig into how that works. These square brackets generate an anonymous module that gets extended or included. It's really kind of clever. But anyway, so here we're saying, maybe C. So out of that array, detect the value C. And so we get some C out of that. And then we can do, value bang on it. And, that will get us the underlying value, and we can do that. And here, maybe Z, look for Z in that array. We didn't get it, so it's none. So, we had just and nothing, and here it's called sum and none, which I like better because they're shorter. They're the same number of letters. But anyway, so now we have none, and if we call value bang on none, we get this unwrap error. Value was called on a none. And so it's a little more obvious like what the problem was instead of undefined method on nil. And so how this is working is, like I said, so sum and none both implement value bang. And on sum, it gives you the value. And on none, it raises an exception. Like it doesn't have to do any detection. Like these are two different classes that implement the same method in different ways. And there's a whole lot of other helpful methods. So like, I skipped ahead. So yeah, say we have two methods, getting away from monads. We have two methods, both can return nil. And so here we're trying to chain them together, and we have to do this if user, and then we have to do if or else. And so, but if these two methods return a monad instead of a nil that we have to check, we can get this code a little nicer to read. So here, find user returns a maybe, so that could be just the user or some user or none. And here the maybe, we're trying to find the name, or that could be none. Like maybe none of that is set. So both the sum and the none implement bind and map and or, and they do different things depending on which one it is. And you can just like chain all of these going off of it. So now we don't need the if and the else. We can just say, so find the user and then try to call friendly name on it, and then try to call hello. And if it wasn't, go do that instead. And so the none just keeps, the none from this, skips this, calls that. And so, so yeah, we have, so the methods. So the first one we saw was bind. And so you can see even how easy this monad is to implement. So on sum, it'll just leave off the initialize. So sum gets initialized with an underlying value. And the bind method just yields the value and returns the return value of that block that you gave it. And on none, it just returns itself again. So it doesn't call the block that you gave it. So if you do sum 40 bind, go do some work, you get the work. If you call none bind to do some work, you just get the none again. This block was never evaluated. So similarly, there's fmap where, the fmap is just like bind, except on the sum, it'll wrap it in another maybe for you. So in this.
And that means like functional map, to be clear, right? That's what that probably means, not like flat map or anything like that.
Yeah, I don't know, functional map probably. Functor map, maybe. So here in bind, we had to say sum, but in fmap, we get to just skip that step, and we're just this block, and fmap will just wrap it in another maybe for us. So it saves us a little bit of boilerplate. And none, fmap does nothing again. And then or is just the opposite of bind, where we call sum or with a block. It doesn't evaluate that block. It just returns the original sum. And on none or, do something else. Wait, that's not right, because D isn't anything. So say that says sum 42, and that says sum 42. It just evaluated the block on none. And on this one, it didn't evaluate the block. And so that's what lets us, and then value, bang, on sum, it returns the value that we gave it, and on none, it raises an exception.
Is there an equivalent like value no bang that wouldn't raise the exception there? Just
No, because that doesn't mean anything.
yeah,
Because now you're back to the problem with nil.
right? Yeah.
I should have had a slide in there about that. So anyway, let's go back to this. So now we, bind map or. So whether this is sum or none, whether find user returns sum or none, we can just call all these methods on it, and it just does the right thing, executes the right code, depending on if we had a user or not. So the reason there's a difference between bind and fmap is because bind, this function we had here, we have a function that returns a maybe for us, so we don't need to wrap it in again. And in this one, we just wanted to do some string So we didn't want to wrap it in success, so we can use fmap to kind of shortcut that. And then or calls it on the other one. So then, all right, so sometimes instead of just a nil, the methods can provide a little more detail about what went wrong. So the maybe monad has a none, which doesn't tell us at all why it's nil. But there's another monad called a result monad, which works basically the same way, but instead of some and none, we have success and failure. Success is the same thing as some. It works the same way, wraps a value. And then failure, however, can have a value of its own, which can be a symbol or a string or any other object, like a hash full of validation errors, or even wrap an exception. And so another feature is monads support case equality, the triple equals method. So you can say, case result, when it's success, do that. When it's a failure of that kind, do that. When it's a different kind of failure, do that. So you can kind of chain these off. The results also implement bind and fmap and value bang and or, and there's a few more helper methods. All right, so now getting back to that simple transaction we had, we can see that the do a thing step is returning a failure or a success, and the failure being like, oh hey, I can't do my job because something was a foo. Otherwise, it returns a success, and the next one, like I said, it can't fail. The transaction runs these all in order that you define them. So it runs step do a thing, then it runs step do something else, and if one of them fails, it stops there, and then it returns the failure that the step gave it. So the caller can go work on that, using the case or the bind. All right, now writing out success and failure can get kind of tedious. You don't want to have to do that every time, and so dry transaction comes with these step adapters, they call them. So here we've got, so we've replaced this step of do a thing with two steps. One is a check step that calls check not foo, and then a map step, which is do a thing. So we split this up into two. We got rid of that if, and so now the first so the first step check, which is a step adapter that if the method returns something truthy, it's a success, and it just passes the argument. It throws away the true and passes the argument on straight into the next step. If the method returns a falsy, it stops and returns a failure. And so then the map step takes, it just wraps whatever you give it, and it returns it in a success. It doesn't do any sort of checking, just immediately success.
What is the value of the failure that is returned if check fails? Is that part of the
I'm
argument?
not sure it's in the next slide, but it's coming up.
Okay.
But
Too early.
But that map calls fmap? That's what that's doing?
No.
Oh, okay.
No, this
All right, I'll figure it out.
those are methods
Something
on
else.
monads, but the thing that comes back out of this, these are just a DSL to simplify not having to write success or failure all the time. So we
Not the same thing.
so dry transaction treats the input and output of each step, or each step method independently, which lets the step adapter do some interesting things. So like the check, this is its input. It got success with some bar object at 42, and this is going to be truthy, and so it returns not this anymore because this returned true. It just returns the exact same input as the output. That's what the check is doing. And so then the output of this step is getting passed right into the input of this step. And then the map is just replacing whatever input is with the return value of that wrapped as a success. So it just discards whatever you gave it and returns that instead. Okay, so now back to that authenticate user transaction we had. There's a few more steps here. So the try step takes a catch argument, which is just a list of exceptions. And so this behaves like the map. So if this didn't raise an exception, it just returns this in a success. If this block of code raised an exception, it catches the exception, wraps it in a failure, and stops right there. And then the T step, so here we're using it to call some APIs and set some honey badger stuff. So the T step like a command line T where you can pipe things from one to the other. Like it just throws it on the floor. Like whatever the return value of this is, doesn't care, return success of whatever it got. So if these fail or blow up or make a mess or segment isn't identified, doesn't care, just keeps going. And so those are nice, just like fire off side effects that you don't care about or you can't necessarily do your work with. And so at TextUs, we've been using transactions for a year and a half, 2 years now. And now that I'm used to them, like when I first started, like this was a little hard to think about. But now that I'm used to them, like this style of code is really advantageous. So like there's no if conditions. You don't have to like keep a big stack in your head and like jump around. You know, there's no guard clauses, there's no rescues, there's no early returns. The code flow is really linear, and each step, you know, is isolated. And so when you're trying to understand part of this code to fix a bug, you're trying to figure out this one, you just read this one. You can basically just ignore those unless, you know, like the input is coming from that one, then you just read up one. You can still ignore what's above it because it probably doesn't matter. So you can really like keep your mind focused on the important parts. And then at a high level, if you want to know what this transaction is doing, you usually just read the step names. You don't have to read any of the implementation. This is just saying, oh, this is going to do this, then it's going to do that, then it's going to do that. And so you don't have to dig in. You don't have to read all of these methods to understand what's going to happen. You can just see, like, oh, okay, that's what that's doing. And then, you know, from the type of adapter you're using, you can just tell at a glance what it's going to do. You know, like if you see T, you know, like, oh, those are side effects I don't care about. Or if it's, you know, check, then we know like, oh, this might stop here because we're looking for something. You know, and then, you know, looking at those catches, you can say, oh, this step might raise one of these exceptions. Okay. So like the code gets a lot simpler once you get a feel for how steps flow. And so the next big advantage is how transactions are invoked and how you handle the errors. So here, you know, here we're initializing it with some config, and we're calling it with some parameters. So like the config is never going to change. You can see we're passing, you know, whatever JWT config we need in here. And then we call it with the different auth token depending on who's authenticating. Like every request, that is going to be different. And then we capture the result, and then we can do, you know, check if it's a failure and do something with it. Or, you know, otherwise, hey, we got a user, yay, you know, call back, you know, it's safe to call value bang here because we already checked if it was success or fail. So that's totally safe to do. There's no way this can raise an exception. But in this code, I skipped over the actual interesting part, which is handling that failure. So the transactions call method also takes an optional block. So the last example, it just returned the result. But it can also take a block which deals with this isn't really the result here, it's a result evaluator, but you can call success or failure on those. And there's a nice little DSL to match against these. It looks a lot like the Elm code to do case all the different possibilities. And so here we're saying, you know, so if this call returned a success, it evaluates the block in there, you know, yielding the value into that block. So now we can say current user. And so, you know, if it was a failure on this step, you know, we can go, hey, 401, give me a token. You forgot to give me a token, or that token, you know, that token wasn't any good. Give me a token. Or, you know, we couldn't find the user because the user was deleted, or, you know, we killed their account because they didn't give us any money or whatever. So we can say like, no, you're not allowed to do that. So here, you know, the authenticate could fail different ways, and the controller could act differently based on that failure without, you know, usually this is done with like raising exceptions and rescuing a class of exception. Or, you know, having a bunch of helper methods that run in order with a, you know, a guard clause, like, oh, did we do that? Oh, return.
I love the Elm comparisons, by the way. This is fantastic. Curious though, if you don't fill out all the cases there on the failure and success, especially those failures, right? Would dry exception or dry transactions actually?
Excellent.
Oh, okay. All right. Sorry.
So since that thing was really
Sounds like a theme.
and I really like, you know, really short, fluent, readable names in my code. Well, here I've renamed the result to on, because then I can just say on success, on failure, and like it just reads great. The only difference is success to on. And it's so fluid. The other advantage, one more slide.
Okay.
So another thing you can do is like, here's an actual controller action in one of our controllers at TextUs. Like usually what we do, we have a few controllers that don't call transactions, but basically all of them just immediately authorize and go off and call a transaction. Because most of them like trigger side effects. Most of them do a lot of work. We want to validate the parameters you gave us. We want to make sure you're allowed to do that. We want to, cast, like in this case, we have contacts have phone numbers. We want to make sure, is that a real phone number? Does that phone number exist? Are you trying to create one? Like, there's a lot of logic happening here. And so, the vast majority of controller actions just do some basic authorization to pundit, and then they call a transaction. And that transaction can, it just handles whatever garbage params we got. Notice we're not using, the Rails safe params or permit or anything. We just give it the hash, and it's, this is safe because we go off and validate it. We don't immediately turn it into an active record object. And then this transaction goes off and let's check those params. Let's see if you're allowed to do that. Let's see if we already have one of these. Let's go do a pusher notification that we created this contact, or maybe we updated it. The name is just changed. It's the same contact, but you created it. So we'll figure that out and we'll go do it. And so when it works, render the contact, because this transaction returns the contact on success. Otherwise, we can handle the errors. And so on validate, so we have a validate step that runs a dry validation, and we can just immediately render the errors with that status code. Or this one has a special, different one that's check for duplicates, and we want to render, oh, hey, you already created a contact with that name, or you have these 6 with that name. Do you mean one of these instead? So we can just return the matches, because instead of on this success it returned the contact, on this failure it returned all of the contacts it could have been. And so then if there's any other kind of failure, you just go render the errors. We don't have any special handling. You screwed up. Here's an error message. Maybe you can figure it out. And so this is kind of like a case statement. Or that's like an else in a case statement. It matches everything else.
Yeah. There's a plural errors in there. Is that just an extra on failure error render?
So
JSON errors. Just copy paste.
I thought I had a slide about this. No. So that failure can be any object inside of it. And so in this case, we might be turning errors. So that might be a validation errors. In active record, if you try to make it with something and you hit save, or you hit valid question mark, and then you can do .errors, you get a hash that has all your error messages.
That's not what I'm actually saying. I'm saying in the bottom one, it says error, and then you render the error.
Yeah.
It's just copy paste. Okay. I was like, oh, where's that?
But anyway, so what dry transaction is doing here, I totally forgot to have a slide on this, is, so the step can say failure errors, which is the errors that we got back from the validation. But then dry transaction wraps that in another failure kind of thing called a step failure that adds on the step name as the metadata. And so that's how, on a failure on the validate step, and then it unwraps it and gives you whatever was inside that failure into this block. And so that's how error is getting through. And error is going to be, I don't know what that is here, a string or an array of something, exception. But yeah, that's probably just going to blow up. But I don't know that this ever really happens.
Sure.
And this line here isn't actually what we have in the code. Yeah, we have I wrote a Rails failure renderer in action controller plugin, so I can just pass the result in. So I was able to get rid of the validate, because basically all of our transactions have a validate. And so this handles the validate. It handles if it notices the error is an active record error because we did save bang and it didn't save. We always want to render those errors in our API exactly the same way. So we just have a generic error handler that'll do record invalid and record unique, or record not unique. And so that simplifies it a lot, because now I don't have to think about all those extra cases.
Are you using the dry validations library along with active model validation?
Yeah, I think I get into that a little. Oh, yeah, here's your question, Brooke. So the result match your TSL is kind of like a it's strict like a type language. If you don't handle all the possible failure values, like here we commented out this catch-all failure, as soon as it hits this code without even running the transaction, it says, hey, you forgot this one. You know, the case, this failure case wasn't handled. And so here we handled one particular one, but we left off the catch-all. And so it's like, there's extras.
Sorry. So do you no longer do the validate failure at all inside of this command object? So
that's what this is doing, that render failure on.
right.
That on is this kind of pseudo error
Sure.
just evaluator object. It's another block.
But I'm just saying, because previously you had the value on failure colon validate, right? So do you no longer have that inside of there so this compiles that would check an error on that? Or is it only saying,
Well,
hey, you're not
I think
doing
it's sort of cheating because this on failure handles all possible failures.
Right.
But it doesn't whine at us because we handled them all. But it passes it into another one. But yeah, since all of our controller actions had basically this line of code copy and pasted into all of them, this render failure basically just takes care of that case for us in every possible situation. And it also handles a few other very common cases that we had.
Sure.
And also the fall through, like, oh, we didn't handle that error at all. So what do we do? Is that a forbidden or a 500? I don't remember. Yeah.
Both.
Remind me at the end, we can pull up that code and see what it does.
Sure.
Okay, so there. Okay, so we're gonna move on to testing. Are there any more questions about that sort of error handling? Okay. So the final big thing that transactions can do for you involves testing. So because each step is defined at a class level, the transaction knows what all of its steps are. In fact, you could call transaction dot steps, and it'll give you an array of step objects that you can go, what are all your names? What order what are your types? What order do you happen in? And so this makes it possible that you can pass in a different step implementation when you are creating the transaction, when you're moving it up. So we then authenticate user. We had a user for token step that went off and what did that do? That looked up a user in the database. So maybe we don't want to touch our database in a particular test. So we can give it a fake step that just returns a failure. It just has to be a lambda or any object that responds to call. And then we can go on and call it with a real token, maybe for a real user. But this thing returns failure because we spelled out the user for token step with this fake. And so here's what this would look like in a full spec. And this is what most of our specs look like. So we can, create a fake user and come up with, some initializer args. By default, we just call it normally. And then we call with these args. So transaction is this transaction new with the initializer args. And then the result is transaction call with those args. So normally, this should just be a success because, we passed the token for this user in. So it says, yeah, that should work. And, until we wrote this spec that says, hey, it should go tell Segment about it. And so then, without having to mess around with the database or do any work, we just give it a fake step here and then say, hey, when I call that like this, it should fail. And it shouldn't go identify the user to Segment because that step before it failed. And so this lets us we usually don't mock finding a user from the database, but we very often fake out so we do texting, and so we need to talk to 3 or 4 different SMS providers. And so we fake out all the calls to the SMS provider at the last possible moment with a fake step that doesn't actually hit the API. And we can say hey, pretend that worked, or pretend that failed. And then you can go test what happened after that. Because these transactions, we chain them one after another, so you come into our UI and you type in a little text field, you hit enter, that chains through probably 6 or 7 transactions to oh, who are you? What are you allowed to do? What account do you? What's your credentials at Twilio? Okay, let's go look that up. And now figure out Twilio. Okay, yeah, let's go send a message to Twilio. And right there at that step, send a message to Twilio, that's a fake step. We can either say success, so it never hits the API, or we can say failure with what we know we get back from Twilio on a failure. And it's okay, it shouldn't send the message. It shouldn't tell pusher that, hey, everybody else, this guy sent a message. It shouldn't send you an email. It shouldn't do all these other things. Or it should do these things, like, it should return an error. And so, this comes in really handy. And we kind of use it sparingly, but, being able to fake out your runtime code in a very obvious way, because you can see right here in this spec, when user token returns this kind of failure, it should not identify to segment. It's really.
Is this a real test?
Not quite.
Okay, I understand.
Close.
Yeah, it's like testing. Because I know this is like borderline testing that you're mocking correctly. Like,
Yeah.
This.
Sort of. But so
Sort of.
pretend instead of.
I do think it's way powerful that you can just swap in.
Yeah.
something.
All right,
Test
so
something
here,
better.
pretend so we used, I don't know if you remember, we can go back. So the identified as segment used a T, which means if that fails, continue on. So what we can say here is say identified as segment returns a failure. It's going to be and then you can say it should identify with honey badger context, or should update the honey badger context.
Right.
So without talking to segment, we can pretend that segment is down and make sure we still don't blow up and update honey badger with the context or whatever. That's it. But yeah, we rarely use it for, I don't know, we ever use it for active record models, we just touch the database, but pretty much a lot of the times when we're talking to third-party clients, we will fake out a step. Or, we're at a fairly high-level transaction, we want to pretend a lower one failed because this higher transaction needs to, lots of times we'll go try something else instead of just giving up. So we want to when that fails this way, go do these other, make sure we did these other things. And so it's kind of nice to be able to switch between that. All right. So another thing you can do is you can write your own step adapters. So we had the base step, which had to return success or fail. Then we saw check and map and T. And so to write a step adapter, you just write a class that inherits from step adapter that responds to call. DryRB really likes their call methods. And it takes, so operation in this case is a step implementation. So it's, what's that called? When you call method on a thing and you get a block. You get a lambda that is that method.
Oh,
I'm drawing a blank on the term for that. It's not
yeah.
unattached, but it's something like that. So anyway, this is that method. And so you can call that method with the input that's getting passed through. And then, here we're if it was, if we got a failure back, return that, otherwise do some more work, and then finally return success. And then you register, the name of your step. So we had T and map and whatever. So here we have one called merge, and we're saying, there's the implementation of the merge step. And so here's one we have that is called a validate step. And basically all of our transactions start with a validate step. And this is dry validation syntax, which is another talk on its own. But here we're saying, I think I removed some stuff, but this is basically the validate step for that context create, where we just passed in whatever garbage params we got from the user in the controller. And here we're saying, you can have a name, and if you do, it has to be a string, and it can't be more than 70 characters. And you can have data, which is a hash, maybe, but you have to have phones, and they have to be filled with an array of hashes that have to have a number and maybe a type. This would be mobile or home or whatever. And so, and here we are converting the phone number could be it could be characters, it could have parentheses and spaces and dashes, and that phone number type is kind of swooshing it down into our common format for phone numbers. And then what we're saying is, then we have this extra rule beyond just the params that is saying, if that phone number looks like it's possible, that's fine. But unless, then say there was an error on that particular phone number buried in that parameter hash you gave us, saying, yeah, that doesn't seem to be possible. And so this happens, I kind of lost my place. Yeah, so we have a valid step adapter that runs a dry validation block and then takes the success or failure of that validation and turns it into a result monad that now the step can return. And then on top of that, we implemented this class level helper that generates a valid step, and generates the method where the block that we passed into this becomes the body of the method. Yeah, so like some of these things would be kind of impossible to handle in active record validation. Like these we have a contact phones model that has its own set of phone numbers that, you can't really say the type of that and get good errors on the outer thing. So here we just want to like give you a contact with a bunch of phone numbers. And on active record, if one of those phone number validations fails, like the others might have already started saving, or the contact might, it's like now you have to roll it back or know which one it was an error on. It's kind of hard. But here, we're not dealing with any of that yet. We just have the parameters, and we're just talking about the parameters. If they gave us any extra parameters, it wasn't listed in these keys, so it just gets thrown away. That's not part of this. We'll just ignore it. That's how we can. So you can't have like admin true in your param. There's no admin field we listed here, so it just gets discarded and ignored. That's how we don't have to have the params permitted stuff. And so the other thing is like, so this transaction gets called when somebody goes into the contact edit form and types in a bunch of stuff and hits enter to save. But we have a lot of other ways to get contacts into the system. Like you can upload a CSV. Brooke's working on a thing now where we just go import it from your CRM. But we probably want a totally different set of validations there. Like if you import a CSV, like maybe there's no names there, maybe it's just numbers, but that's okay. Whereas if you're typing out a contact, like maybe we want you to have a name. So this one might say required name, where that other transaction would say optional name. And rather than having to, on the contact model, say, I guess we don't know. We can't say it's required because in some cases it isn't. And you can sort of do that with like ifs or whatever. But here, since each of those come into the system through a different transaction, we have a totally different set of validations and a different set of rules for those two code paths. That's another one. Because of our talk yesterday, Brooke, I updated this slide. So you should understand this better. So here we have, so these are kind of two ways of doing this. Like early on when we were writing these steps, we very often wrote like map user, but we passed in a bunch of arguments that we didn't want to lose. So we had to like capture the keyword args the rest of this method took. Because a bunch of stuff is coming in here. We need user ID later for whatever reason, but we just want to go look up the user in our database. So we had to like capture the keyword args, merge the keyword args with the thing we just did. And so what we, so here we start with user ID 42, name Chuck Norris, the output user ID 42, name Chuck Norris, and a user object. So this was happening so often, I extracted a merge step adapter. So what this does is now so it works a lot like the map step, but instead of just blindly replacing the input with the output, it tries to merge the output of this method into the input. And so if the method returns just a value, it creates a single item hash with the key being the method name, and then merges that hash into the input hash. And so we can the other thing it does is if the step returns a hash, it merges the return hash into the input hash. But because of the way Ruby keyword args work, if I were to leave these off, it would say like, oh, hey, you gave me a user key and this method doesn't accept a user key. So what we do is we just accept them and ignore them. Because now when we get out of this step, it has merged this whole hash together. But so, email is coming from, so the output of this is the user from up here, the name from up here, the user as a result of this step, and then the email and number of fists as the result from this step. And so the merge step may also return an explicit failure, in which case that'll just stop it to be a failure. Okay, so there's another step called use, and that's how we call other transactions. So all of these things are transactions. And so, segment identify in that one thing was just a single method call. But if it's more complicated, we may want to break, if it involves 3 or 4 steps to talk to segment, we may want to break that out into its own transaction. And so what we can do is we just say use other transaction. And in fact, this can be any object that responds to call, and then let's go call it. But it has to return a result so that it can go on to the next or not. And so here, we're merging in a user, merging in lookup metadata like we had before, and then hey, go update that user, and then go sync them with their provider or whatever, and then go call segment identify. And so it's gonna go, this might be 10 steps, this might be 2, this might be 4, but it's all broken down, and we may use this 10 different places in 10 other transactions. But it's just here's this little block of code, go call it. And then outside of here, if some step inside here fails, that failure works its whole way out, and you can handle it just like any other step that failed. So then building upon the use, we have and validate, we have a maybe. So what this does is it works like the use where it goes to call it, except if that transaction has a validation step, it will try to call that first. And if the validation fails, it doesn't, it's oh, okay, that's fine. It goes on to the next one. It's maybe, we can't, oh, they're already fresh enough. We don't have to go, or we already told segment about them. So the segment identify transaction could be validate user is old or user is new, and then it runs. But if the validate fails, well, the user's new enough, that's fine, keep going. So it kind of can pre-flight running the transaction and then just not fail. We use this quite a bit for just random side effects that, get the system in the right state when it may already be in the right state. We just check, is it in the state? Okay, we don't care. Don't, if validation fails, keep going. But it won't fail the whole transaction. And then building on that, we have async. So all of these run in active jobs. And so maybe, this is an API call somewhere, and this is an API call. And so now we can just fire off all these background jobs, maybe. If the validation fails, don't enqueue a job, don't worry about it. So all of these step adapters are kind of building upon each other. I think that's all I had. Yeah. Conclusion. So, yes.
Sorry, can you go back to the previous slide real quick? I'm just curious if you fire up all this stuff to segment and segment's down, or how do you differentiate between segment being down, intermittently, like a network issue, and a bug that someone caused that is causing a failure to write segment, and you're just ignoring all these?
So if the validation step, only the validation step fails, that is okay, we'll move on to the next step.
Mm-hmm.
If the validation step succeeds, it will call that transaction.
Okay.
If that transaction then fails,
that would bubble up.
That's a failure, and it bubbles its way out.
Okay.
If it's async, that's a background job. It's just gonna go retry your normal rules.
Sure.
Or the other thing you can do is we have a transaction job that is just a very generic job that follows our normal active job rules on the normal queue. But if you need to change any of that, or you want to handle the errors in a special way, you could just say async sync provider job, and it would go call that active job the same way. That way I have just a thing that mixes into active job to give it a validation step, the same, validate do DSL at the top. Okay, yeah, that's it. Any questions? Remind me to show you that thing. Yeah.
For third-party integrations in your test where you're stubbing out those return results, how do you catch they changed their API to a value that you no longer?
We don't handle that. This doesn't handle, just like any other mock wouldn't notice.
Is it, I think what he's asking is there, or what I'm asking on top of that is there another place where you test, maybe occasionally that, hey, this call still succeeds at this?
So this transaction calls this transaction, calls this one, which does the work. And so we will test the hell out of this one, making those API calls. And sometimes, when you're writing it, you don't mock anything. You let it make those API calls, and I kind of capture those responses. We have a bunch of tooling in our app to make that easier, fake out HTTP without using VCR. But then out here, you can now fake this step however you want. So you kind of draw a line there. Like this thing is going to exhaustively test the API, and everything before that is just going to pretend that works. Or in these special cases, we're going to fake out, hey, this failed in this way, and we can go test things about that outside of the transaction. But for the most part, we do have some. We're just starting to use Cypress for like full end-to-end integration tests, where we it drives the browser to go click on the things. And I'd like to eventually get that to like sending real SMS messages and talking to Segment and talking to Pusher and making sure we get the update notification in the UI. But we're still a ways off from that. But that's kind of a separate concern from these transactions.
And just to comment, I mean, this is super cool, and I don't mean to talk about JavaScript at all, but I'm going to. But the functional JavaScript book, I think it's Manning's. I read it like 4 years ago. It covers all this maybe and like all this stuff he talked about. It's like, if you're interested in the JavaScript perspective, I think functional JavaScript is the book that has it. It blew my head off.
Yeah, spending a couple weeks with Helm is probably the easiest way to get some experience with monads.
That view library though. Sorry, I'm gonna say that.
I broke his tree.
Yeah.
I hate it. I was like, I love Elm, but I'd like, make me love it.
I don't know, Tim. We're gonna have to have first.
Tell me why it's good sometimes. Not today.
Whole presentation.
I just mean view library. No.
Okay,
that's all
Chris has a question. Yeah. Oh,
Is there any significant overhead by pulling in all that extra syntax and DSL?
probably. Haven't noticed any.
Okay.
Ruby method calls are microseconds. Talking to the database is can be tens of milliseconds. So
Actually, so kind of to add on to that, you do have to be kind of careful in some of those dry libraries. Like, for instance, if you do like micro benchmarking and stuff, and you look at take dry struct, for example, in the dry libraries. If you pick one of those, it's powerful. It's a powerful construct that you can use in your Ruby code. But if you do micro benchmarking on the performance of dry struct versus just struct in the Ruby language, or maybe even some of the other struct gems out there like values, and the other one that's kind of popular now, I think it's semantic struct, I think is what it's called. But if you do some of the performance micro benchmarking on that, you'll actually see that they're slower, quite a bit slower actually. So you might, if it is a hot code path in your code base, right, you might want to actually do some benchmarking there just to kind of test that, because it can potentially be slower in some of those cases, where you might just want to just leverage native Ruby at that point. Yeah.
So this is that action controller written that handles just arbitrary failures. Like the fall through, we pass the evaluator in here. And it's just a few more of these on, a lot of our transactions have an authorized step. So it's like 404. I don't know any more than that. And on validate, we always want to give you the errors that we got structured the same way. And then, on any other failure, if it was record invalid or record not unique, say that, or otherwise, it's just forbidden. There we go, JF, it's forbidden is our fallback. And then we just render whatever was in there. We haven't really spent a lot of time on what all of our error documents look like, but for the most part, things fail invalidate or something is really wrong that the user can't do anything about anyway. Let's see. Cool. So the question about baking steps. Yeah, here we go.
Don't we just send an NDA for this, Paul?
Yeah. Okay, so this doesn't work quite like I thought it did, but here we are. We're faking this. Oh, we're faking an adapter. Okay. Yeah, I don't remember offhand the name of, because out of all of our specs, it's probably 2 or 3 where we fake a step with a failure. I just didn't need it that often. I don't remember who was asking that about. Yeah, we somebody. Yeah.
Are you guys using other gems from that suite that you didn't really speak about that you found helpful, or is that pretty much?
Can only do one thing at a time, sir.
Maybe the bus on the leave, sorry. Good stuff. I
Yeah.
thought I was gonna hate it, but like,
Here's the real one. This is the real
Like, I never used
implementation
this.
of
Actually,
create
I used
contact, and here we do a bunch of really simple, like small chunks of code. Wow, hangouts. That's gross. Yeah, I'd say 90% of the lines of code in our app live in transactions now.
Oh, one more.
Gems we use, validation, transaction, container. Yeah, that is another half-hour talk or so.
Oh, back on your params thing, there's an optional and then it says maybe. Is that maybe as in, like it could be this, or it, like, you
So
may.
this is dry validation, which is probably a lightning talk or another 15, 20 minute talk. But anyway, this is their DSL. And so what this is saying is of the hash you gave me, in those params, it must have a key called account that has to have something in it. So you couldn't just say account nil, that would fail this. It must be filled. And then
Like the optional type maybe string. Like the fifth line down there.
Line 19.
Yeah, line it.
up where I am.
The,
So yeah, what this is saying is, so you must have a phone's key that must be filled with an array of hashes. And inside those hashes, you may have a type key. And if you do, it can be nil or it must be a string.
okay,
if
so
you
if
tried
you
to
pass
give-
in a number with that.
Yeah, if you gave it a number or a hash or an object, it would say that's not a string.
I see.
But a nil would be fine because, so
That's what maybe.
this first part is the key must be present or not between required and optional, and then filled and maybe must be because there's a value or not.
Is that maybe sort of in the background, that or syntax, where it's like, hey, it's not like that? All right.
Yeah, but then you get some other predicates like, here's how we check the size, and then here's how, we check, that one I showed you where like it has to look like a phone number or be something we can convert. So if you pass in so you could pass in like the string one or the digit one, or you pass in strings or digits, it'd be okay. If you pass in 20 digits, it'd be that's not a phone number. If you passed in a string with, paren 303, close paren, space 555 dash 1234, yeah, that's phone number. And would convert it to our phone number. Is what that's doing. So there's probably, I don't know, half the steps in our transactions are merged too. We just kept using that one a lot. Anything cool you want to add, JF? What am I forgetting?
I don't know. I mean, all the validation DSL kind of changed. So I kind of like the rule syntax before, but
Yeah, dry validation recently hit 1.0, maybe a month ago. And that params didn't used to be there. Everything was one level higher. They added that. I had to go fix all that. It's been kind of fun watching Brooks' brain leak out of his ears.
just talk about the tap step. I like that one.
I skip tap. Tap is like T, but if the thing fails, it fails. Where T, it doesn't care if it fails or not. So it's good for firing off side effects where if it didn't work, we want to know.
Yeah, to add to Paul's comment there, the interesting thing is if you are a big fan of composability, right? So small objects, single responsibility principle, small objects, dependency injection, you build up your more complex objects by injecting these objects into there. This still leverages that quite a bit, but the thing that's been most interesting in some of the discussions that Paul and I've been having is I've been a big fan of like structs and staying at a lower level, being able to describe my data and then be able to inject those in so that with structs, then I can create these kind of custom types within my Ruby objects, right? The one thing that's interesting about this that Paul and I were having a discussion the other day is that there's more power in this on the dry side of things, because especially with the validations and the params, you're basically kind of building up a struct in a way. But what you don't get with structures, right, is when you build those out, is you don't get the validations out of the box, which you have to work a little harder when you're using structs. Not too bad, but you can get around it. But that kind of gives you that structure, so to speak, but then also the validation with it, which is kind of neat to think about if you're reaching for something that like that.
The big one is if you try to create a struct and then you don't give it enough keys, or you give it too many, it yells at you. Or if you didn't give it enough, it says, hey, you forgot this one. You're like, okay, I'll give you that one. Hey, you forgot this one. And so like you have to like do that one at a time. It stops on the first. Where the validation's like it tries them all. And like, oh, that failed, that failed, that failed. And it gives you an error that says, hey, these 3 things failed. And so you can go work on that and get a nice message for the user, like, oh, you forgot to fill out email and name and phone number. Just like an active record validation can do. Like it doesn't stop on the first error it gets.
Yeah.
Whereas a struct, like it doesn't know that you want to keep going and get good errors. It's just like, hey, I'm missing that key.
Yeah, I guess, yeah, and to kind of give this more concretely is my first instinct, like especially when you're dealing with third-party API, is I want to take the API and the structure that they get back from me. And my first inclination would be to actually wrap that into a struct. I want to build this a structure out of this so that I have a type, something I can work with and something I can talk to. So I'm not dealing with primitive obsession and actually digging things out of this hash, right? Because that's pretty dirty. But like Paul points out though, is that can be, I like the rigidness of that, but that can be kind of dangerous because if the third-party API changes, they give us too many keys, or they give us too little keys. Actually, in a little case, it's not so bad. But if you get more keys that the struct doesn't account for, you get an argument or a key error. So this is a little bit more flexible in that regard. So in case that helps for context.
Yeah, who's been doing Ruby and Rails for like more than 2 years? Oh, so about half. Wow. Like more than 5? 10?
Yeah, right at 10.
Old farts.
Yeah. Thanks, Jim.
So like this is a pretty, I guess I didn't know what my audience was going to be when I wrote these slides. So I hope this wasn't too much, or like if you have any questions, like feel free to tweet at me or
Tech Friends.
Yeah, I'm in the Ruby channel on Tech Friends. That's probably a great place because I don't answer Brookwood. Yeah, I'm sure this was like a huge departure from what you learned at Turing.
Oh yeah. Yeah, I mean, once we started on this path, like at first it was overwhelming, and then now like I can't imagine if I approach another project not having that influence of trying to do this like railway oriented programming style. So yeah, I think it's nice, and it makes grokking whatever your new code base part you're looking at way easier.
Yeah, in my extreme amounts of free time, I've been working on a side project, and I don't know, I got maybe 2 or 3 days in. I was like, the hell with it. I'm just gonna like copy all of this code from the TextUs app into this app because I need these step adapters. I need this render failure thing. Like, how do I write an app without these now? I'd like to package our step adapters up as a gem.
Actually, on that note, how long did it take for your brain pattern to start switching over?
How long have we been doing this? 2 years? No, like
Just under.
Yeah, so we had an old app that was long standard monolithic Rails app. Like all the work happened in controllers or models, and it was gross and hard to work on and hard to test, and like kind of just on my own. Like there were rumblings that this is kind of a mess. Maybe we should greenfield this and like start over because we're gonna have these bigger customers. We're gonna need to do different things. I was like, on it. And I was heads down for a week. I just like started a new app, and I'm not gonna try out all these things. And I kind of like I've been using command objects. Like there's a much lighter weight gem, Rectify, that gives you command and query form object. One other, I don't present, or a decorator. But like, it's really simple. It's just a method that responds to call, and then it uses like whisper to broadcast things. And I've been using that off and on for a while, and it was a much nicer pattern. And so when I started this app, I was like, there's got to be a better one of these, right? And so like we've been using dry validation because it's sort of the only validation library out there that isn't active record. Where then that's discovered long ago that lots of times you want to validate different things depending on what code path you're coming in on to write to the same model. So you can't have those validations on the model. They have to live elsewhere. But the only other validation library is dry validation. And so I kind of got familiar with it from that. And every once in a while, like since I knew dry validation, I'd go see what other gems there were and I'd go read their source code and be like, oh yeah, that's cool. Like, oh. And so when it came time to like, hey, we need a command object to do this thing. I'm gonna play with this dry transaction. I'm gonna spend a couple days on it, just see how it feels. And it was a really big departure. Like, it was a big mind shift. And like just tinkering with their steps. And then over the next 6 months or so, maybe like, we discovered that, oh, we're doing this merge all the time. Let's just write a merge step. Let's see what writing a step adapter feels like. And then that, deleted half the lines of code because we don't have to write keyword args.merge over and over and over again. And then we were calling other steps. We have like, step, call this transaction, def, call this transaction, transaction name, .call. So like, yeah, let's just, what should we use? We'll just use this transaction. And then we're like, we added the validations because we started getting ones that had input coming in. It's like, well, let's validate all these params. And so then use, like, what if we like pre-flighted it? Like, don't call it if it's not going to work anyway. And so then, we came up with the maybe step. And then once we had maybe, like, oh, let's just background these. And we can use that same validation pre-flight check. So like, it won't even enqueue a job if it can't run. That's also really handy because things like Sidekick, or we used SQS, like you can't really give it you can't give Sidekick a model at all. It just doesn't understand. But like, since we're coming through these transactions, we're merging these big hashes that are just getting passed to the next step. And then you go try to call this job, but you have way too many args. You don't need that. You need this one ID to get passed through. And so having the async job run the validator, since the validation filters out all the keys that you didn't specify, it throws away all those parameters and just enqueues the job with the things that made it through the validator. And they've been typecasted by that. So now the message payload on the queue is small and exactly what you need. And so when it comes time to run the job, it runs validation, which just succeeds because you already ran it once. And then it can go run the whole rest of the transaction. And then these step adapters kind of came. I think it's sort of solidified. I don't know that we've added much in the last 6 months, 9 months.
No.
But we still have, we write a few transactions one way, like, oh, we discovered this new way. Let's start writing them like this. Like, oh, hey, here's this other cool thing. Let's start writing them like that. And so we have these old ones that are just not quite the way I want them written going forward. And so when we hire someone new like Brooke and I sell him, hey, go write a transaction, he's like, okay, I'll start reading through transactions. He'll stumble across one of the old ones and write them that way. I'm like, oh, no, we don't write them that way. And like, that's partly me because like, I'm constantly tinkering and figuring out and like looking for patterns. Like what's the one we have now? Like, we still need a state change step. We use lots of state machines in a lot of our models so that they can only go from one to another. Like we have
Pusher step for sure.
Yeah, so we have like messages. And as part of, so a message can come in, and so that's received. And then when you send a message, maybe we created it, and then we go put it on the queue to be delivered. And so we scheduled it. No, not scheduled, what's that? Not dispatched, that's next. That's between created and dispatched. Anyway, there's another state there, like, hey, we're getting ready to do this. And then we've dispatched it, we've sent it off to Twilio. And then Twilio, after a while, sends us delivery receipts, so we go look up the message and put it either in, we delivered it. And all those are state machines, so that like, sometimes Twilio will give you so Twilio you post to their API with a message and a callback URL, and they call back saying like, okay, I'm trying, okay, I'm done. But sometimes these happen out of order. Like it'll say, I'm trying, success, I'm trying, like, because they came out of order. And so you don't want your message to go back into the, schedule or the queued state. And so you use a state machine like, you can go from queued to sent, but you cannot go from sent to queued. And since the things that handling these receipts is a transaction, it calls the state machine to say, oh, hey, we got the Twilio's done message, transition that message to sent. And then, oh, we got the Twilio in queued message, transition that message to queued. But, oh, you can't do that, blah, blah. And so that's a step failure. So the whole transaction stops. We don't send out the pusher notification. We don't update the message. We don't do anything else after that. But we don't have an explicit step adapter to do those. I've been kind of meaning to write one for a while, but just haven't had enough pain yet to do that.
Back on your slides to the first one, because it took a while to record and you changed. I'll fix it in post.
Okay.
Famous last words.
Alex will fix it in post.
Cool. Make that thing go away. Go away thing. There we go.